Welcome again. My name is Andrew Thomas. I'm a AI specialist at Microsoft. We cover everything from the AI services, so AI search, et cetera, to now our Azure OpenAI service and all the relevant models, as well as our machine learning platform. And I just want to call it, I love the way Brian started his presentation. I wish I had done that just to see the rate of adoption for GenAI. It's really incredible, 5 weeks to a massive user base. With that, comes responsible AI concerns and security concerns. Those are some things I'll touch on today. Just to start off with our highlighting the Microsoft and OpenAI partnership. As you know, Microsoft was a rather early investor in OpenAI, started off with an ask for Azure credits and moved on to a much broader partnership that delves into our AI infrastructure, model building, and so much more. So our missions are stated here, right? OpenAI wants to ensure that AGI benefits humanity, and Microsoft is out to empower every person and organization on the planet to achieve more. And we think that we do work better together. We're grateful for this partnership. And you can see all the models that have come out of it down there at the bottom. The latest announcement, obviously, is the O1 series. It's a very cool suite of models that has what we call Ph.D. level reasoning. We'll get into that in a bit too, as well as your GPT models that have been around and have been ongoing updates for the past year plus. So some new announcements for Azure OpenAI Service. We recently launched data zones. This has been a long time ask from our customers because we had previously matched OpenAI's deployment model of a global endpoint where these servers are all around the globe. We have a load balancing algorithm that takes place on our side to direct traffic wherever it may need to go. Now we have regional and data center residency options for you so that you can get the benefits of multi-data zone or multi-data center compute while also remaining within a region for compliance purposes. The O1 models, obviously, talked about that. I'll get to that a bit later. Batch API is a cool one. This is where if you have LLM prompts and answers that you want in an asynchronous fashion, you don't need them right away. You can get a 50% cost discount by going the batch route and deploying, sending a bunch of requests at once. And usually within 24 hours, you get a turnaround through a JSON-L file. The 4.0 audio model, this is a really cool one. I'll try and demo it for you all if technical issues don't hinder me here. This is sort of real-time, low-latency speech interaction. And if you've used the Microsoft Copilot app, you'll have seen this in action. This will soon be available for customer use. And one thing to caveat all these announcements, I'd encourage all of you to keep an eye on the Ignite conference that's happening next week. We have a lot of further, GA, private preview, public preview announcements coming there. So all eyes to Ignite. When it comes to provisioned, or PTUs, as we call them, provisioned throughput units, this is sort of our model for quote unquote dedicated capacity, to where if you go off a pay-as-you-go service, during peak hours of the day, you may have what we call the noisy neighbors that increase your latency and make it unpredictable. So we have options there. Another recent announcement, fine-tuning for the GPT models has gone general availability. So now, right in the Azure OpenAI portal, you have the option to proceed with fine-tuning, and we can handle hosting for you in a couple of methods. Structured outputs is the last announcement here. This is for use cases where you'd want a JSON output, something that you want guaranteed to be structured. Sorry, in person, I think Ron will have to get rid of that cover there. But yeah, options all around. Hold on, let me go ahead. Oh yeah, can just hit the Windows key, I think. Much appreciated. There we go. Cool. So I know cost was one of the cost and load balancing were a couple of the the items mentioned on the website, right, in anticipation of this. So I just wanted to highlight sort of the differences between our various offerings and what would be best for you in terms of a practical deployment. So standard is what we call pay as you go or pay go. This is ideal for most use cases. If you're just wanting to start off and try it out or trial it, this is, you can get a certain amount of quota in terms of tokens per minute and requests per minute allocated to you in the Azure portal. And then you will have access to up to that amount of request throughput from your API. The problem with that is, again, when we get to peak times, this is shared infrastructure. So while your prompts and your data is not being shared in any capacity, the compute behind it is being shared. And this can lead to, again, the noisy neighbor syndrome. So that's where we come on to provisioned. Provisioned throughput is your dedicated capacity in our data centers. So any time of the day you want to send a request, or even peak times when you have lots of users concurrently, this will allow very consistent and predictable latency. Getting rid of that variability is important for more of those real-time use cases. But again, if that's not important to you, you can go on to batch and have things processed overnight, perhaps for data science type projects where you want to evaluate bulk LLM requests, things of that nature. One sort of tactic that we encourage is to mix the standard and provision offerings. This way you have a baseline of predictable, latency throughput, but then in case of super peak times or stuff that you didn't anticipate, you can spill over to the pay-go infrastructure, so you won't be denying any customers away. Now going on to your deployment type, global, data zone specific, or regional, this will really come down to the constraints of your business and regulatory requirements. So for businesses that really don't have these type of constraints, we usually see this with government customers, where they need to keep their data onshore in the US, or for European customers within the EU, or even within their own country. So for country specific or even region specific, such as Southeast US, we would go with regional. If you can expand to a country but not beyond it, then we'd choose data zone. And if you really have none of those constraints, we'd go global. And obviously the performance goes in the inverse, right? So global will typically give you the best performance due to the wide availability of load balancing. Data zone slightly less, and regional slightly less. But if you go with provisioned on any of these offerings, you can expect very predictable results. So sort of tying these two concepts together, these are all mix and match type offerings. So you can have standard global, batch global, provision global, or any of those three in data zone and regional as well. So we have a lot of flexibility when it comes to these offerings, and just wanting to give customers really as much choice as possible. So let me know if I can clarify anything on this front. Any questions, happy to answer. Before I go off this topic, API Manager, or APIM on Azure, is really our tool to go about load balancing across these various offerings, between provision standards, even multiple endpoints. Although I'd encourage not to handle the load balancing yourself, I would use this for spilling over from your provisioned to your standard. In case you hit the peak number of requests per minute on your provision offering, you can switch over to, or spill over to standard pretty easily. As far as data center load balancing goes, I'd say let us handle that complexity with a data zone or a global requirement. Alrighty, moving on. So you may have seen a number of updates in the past year in terms of multimodal models. This is a very, very exciting development in the LLM space, because now not only can you chat with it over text, you can speak to them. You may have seen a demo of GPT-4o, or the Omni model as we call it. You can take out your camera and show it the world, giving this model eyes to see and have it reason over the real world. It's really cool stuff, and I encourage you all to try it. When it comes to our latest flagship, the O1 models, this is, again, the PhD level reasoning. So there's two models, O1 Preview, O1 Mini. This naming can be a little bit confusing. I'd say we should have put a preview after Mini as well, because both of them are in preview for the time being. But the big differences here, O1 Preview gives you the top of the line, state-of-the-art advanced reasoning for solving complex problems. It enhances the LLM's underlying capabilities by actually having multiple personalities under the hood. So the exact mechanics of this are trade secret, but we speculate it's based on agentic architectures, where if you see in libraries like AutoGen and others, where you have multiple personalities under the hood that check each other for various aspects of an answer and various aspects of reasoning before finally outputting that answer to the user. This is really where that comes into play. Mini gives you an 80% cost reduction while still offering some of those benefits. So it excels at instruction following, small context operations, and code debugging. Some of the use cases that you might want to try out the O1 models for are for generating complex code, even giving it an understanding of your code base, in-depth problem solving and brainstorming, and then comparative analysis or instruction following. When it comes to model guidance as to when to pick the new ones over the old ones, I just want to be clear that these are not replacing the old models. O1 is meant to be a different class, a different category of its own. So for problems that require advanced reasoning, complex problem-solving skills, often involving math and science, that's when you want to lean to the O models. For traditional chat-style interactions with users, or even RAG-type scenarios where you need a faster response time, I'd say stick to GPT-4o and 4o Mini. And just for some benchmarks for everyone to see the improvements of O1 over 4o. Here we have, all the standard benchmarks. MMLUs is really sort of the gold standard in the LLM industry. But then we also have performance on a number of exams, AP exams, law, etc. So all that being said, I'm going to try and switch screens here to show off a little bit of a demo. All right. For O1, I'll go ahead and show a little video or a portion of a video. This is OpenAI researchers creating a game fully using the O1 model. Super cool. That's good.
And displaying instructions before the game starts, etc.
So the researcher here has given the O1 model a series of instructions to create a video game. Use Pygame to make a game called Squirrel Finder. It gives it a series of rules, and mind you, it tells it to give the code in a single file, and that's it. There's no additional instruction, and you'll be able to see here just under the hood how the O1 model works. It's very impressive. It will tell you.
And to give a brief overview of the prompt, the game Squirrel Finder basically has a koala that you can move using the arrow keys. Strawberries spawn every second and they bounce around, and you want to avoid the strawberries. After 3 seconds, a squirrel icon comes up, and you want to find the squirrel to win. And there are a few other instructions like putting OpenAI in the game screen and displaying instructions before the game starts, etc. So first you can...
Yeah, here we can see the model thought for 21 seconds. It was giving all these steps as it was doing it, but describes the game, shapes it, organizes the code, crafts the solution. The reason we call this PhD level reasoning is because it's coming up with a plan before it executes a problem. And even though this was sort of a prompt engineering technique prior, it needs no explicit instruction to do so. With its under the hood reasoning, it's doing all this without even being asked to do it, coming up with a plan, crafting a solution, generating code, and ultimately coming up with a...
Oh, the squirrel came very quickly. But, oops, this time I was hit by a strawberry. Let's try again. You can see that the strawberries are appearing, and let's see if I can win by finding the squirrel. Looks like I won.
Yeah, so super cool stuff. Again, this goes back to the partnership we have with OpenAI. Part of our agreement is, we supply them with the compute, the infrastructure to come up with these great innovations. And then at the end of the day, when they do come up with these models, we offer it to our customers on Azure. It's really a great win-win scenario. Again, if people have questions afterward over what use cases would be good for this type of thing, we can definitely discuss that. When it comes to the real-time API, I hope this works. I know Zoom is using my mic. Let's see if Copilot can hear me. Hello.
Good morning, Andrew. How can I make your morning a bit brighter?
So I'm presenting you actually before an audience right now at the Angelbeat seminar in Charlotte. Just a little bit nervous. What would you want to say to the audience?
Sounds like a great crowd. I'd say, hello, Angelbeat seminar attendees. I hope you're all ready for a dynamic session with Andrew, who's about to bring serious insight your way. And Andrew, don't
I
sweat it.
appreciate the hype. Sorry to interrupt, but let's say for the audience here, it's largely an enterprise crowd. How could we use this real-time speech technology that you use in a use case with businesses and their customers?
Lots of ways. Real-time speech tech can boost customer service with voice-activated virtual assistants, enhance security with voice biometrics, and even streamline meetings by converting speech to text for instant transcriptions.
Very impressive. Well, I appreciate it. Thanks for being part of my demo.
Absolutely. Enjoy the rest of your seminar, Andrew.
Very cool. So this is available to all of you via the Microsoft Copilot app. But more importantly, for the business-focused audience, the underlying model behind that real-time, quick response is available or will be available soon as an API. And this will enable, countless scenarios. Even if you just want to use it as a companion, I'd say go with Copilot. But for business, call centers, I think the list goes on. I'm blanking on specifics right now, but let your imagination run wild. Whenever this comes out of public preview and into general availability, that's the type of latency that you can expect from these models. So thank you for humoring me there. When it comes to the cost of such models, again, the ones with reasoning are going to be a bit more expensive. Just as a general trend, I want to point out that model costs have kind of diverged in two separate directions on the whole, just industry-wide, right? The legacy models, the ones that are, traditional RAG, even voice, they're coming down in cost a lot, anywhere from 6 to 20x. So this is great for customers, great for businesses. You get to use more tokens, and at the end of the day, you'll probably pay less for it. On the other hand, we have these reasoning models and sort of cutting edge models that are coming out at a higher price point, but that offer a higher value to the business in different use cases. So I would say out of the whole catalog, there's no one size fits all. There's no one right answer. Definitely see which applies best to your use case, and all those different models that we talked about earlier in terms of offering these within your tenant to your customers are available for each model. So that's a little bit on OpenAI. Going beyond the OpenAI portfolio, though, Azure does support a number of others. As of last writing, 1,600 plus models from Hugging Face, Meta, Mistral, Cohere, even NVIDIA's Nemotron recent edition. And yeah, there's, did I miss any? Let's see. Databricks, Snowflake, yeah. Oh, and then of course our SLMs, small language models such as Phi, which have been opened the door to like fine tuning for specific use cases in order to reduce cost even further. When it comes to these non-OpenAI models, we give you two paths for hosting. We offer model as a platform and model as a service. It's really up to you and your business as for which path you want to go down. But just to give a little bit of a broad stroke here, model as a service it's software as a service, essentially. It's a pay-as-you-go endpoint where we manage the compute, we manage the infrastructure. You can call the API with whatever quota you're granted, and it's only offered for a few select models that are built into the Azure MaaS service. Model as a platform is much more flexible. You can get open source models on Hugging Face and deploy them this way. The cost model behind MAP is the compute. So you're paying an hourly rate for whatever compute is minimum SKUs necessary to host that model, and you can make as many calls to it as that compute will allow. In both cases, all the various features that we offer in AI Studio, such as responsible AI and others, are still supported. When it comes to benchmarking these various models, AI Studio has you covered. There's a dedicated benchmarks tab that you can use to track your model's performance by endpoint, by region, so on and so forth. And then even for model evaluation, we have built-in tools for you. So some of the common industry metrics for LLMs, such as groundedness, coherence, fluency, relevance, the list goes on. You can put in sample data and run a test on your own, or you can run ongoing evaluations on models that you have deployed to customers. In addition to all these, when it comes to the mass catalog, for some of the industry standard benchmarks, such as MMLU, whenever you click into any one of these models, it will give you a breakdown of various benchmarks, so you can see it off the bat and make your determination right then and there. I had mentioned fine tuning, especially when it comes to SLMs. This is also a service we offer for both OpenAI and for models on our mass platform. So this also goes in two directions, right? We have fine tuning as a service, essentially, where we'll do the hosting for you. You just provide the training data that you want in terms of question and answer or input and output pairs in a JSON-L format that you want the model to be fine-tuned on. You go through various steps of importing the data, stratifying it into test, train, validation, and finally running the job on managed compute. For those who want to go the map route, we offer that as well. Model as a platform, again, the only cost to you is the underlying compute. So with mass, there's a hosting cost at a fixed rate. With map, your compute is the only cost. And again, happy to take questions on this. Fine tuning is generally regarded as a I wouldn't say a last resort, but close to a last resort. So, prompt engineering is definitely number one. Grounding on your company's data with RAG definitely should all be tried in depth and with all the industry leading techniques before getting into fine tuning, because it's a difficult task to achieve. But you can imagine a cost curve to where if you can fine tune a small language model such as Phi to perform a task that an LLM would do very well off the bat, then you can overcome the fine tuning costs over time, because as more and more queries come into your specialized SLM, you end up saving money in the long run. I want to touch on prompt flow. This is another feature we offer in AI Studio. And again, you can use any of those other models that we had touched on before. This is sort of guiding an end-to-end flow. You can have Python scripts in between. You can have Bing search. You can have your own grounding on your own data, as well as multiple LLM calls. So I would say the use cases for prompt flow are more so in development. When it comes to productionizing prompt flow, we do offer that. But I would say with the release of O1 and sort of the built-in reasoning capabilities that are happening there, I would lean to evaluate on that model first before going through the hassle of prompt flow. But it's always an option. I want to touch a bit on responsible AI. This is huge for us and for our customers, and for all of your customers as well. The onset of GenAI has introduced a variety of new risks that we haven't had to deal with before. Ungrounding, jailbreaks, prompt injection, callback to SQL injection, harmful content and code that can be generated, copyright infringement claims, and also manipulation and runaway rogue model behavior. This matters to all of us because 72% of consumers want to know a company's AI policies before making a purchase, because if you're going to deploy our stuff, ultimately your company's reputation could be on the line. if the model performs poorly, and ours as well. So we do have some core principles that I'll touch on. Just to level set, though, we're built on trust. Your data is your data. When you use OpenAI models on Azure's platform, it is not being used to train the underlying foundational models. I hope this much is made clear by now, but it's always good to reiterate. Your data and your models, even models that you fine-tune, they're protected every step of the way. We also have a customer copyright commitment to where if you use our safety tools, such as content safety and others, we will cover the costs of a copyright lawsuit. So more fine print on that on our website. But really, for an overall responsible AI framework, these are the key principles that we focus on: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. And we have a tool called the RAI dashboard that you can use to monitor your deployments for these various metrics. We have the Azure AI Content Safety Service that you can deploy with OpenAI or other models. This can be used to detect various categories that you would not want your model to be outputting. So for some examples, violence, hate and unfairness, sexual content, self-harm content, etc. The way it works under the hood is it uses actually an LLM to evaluate the outputs of your LLM. So a bit meta if you think about it, but it tends to work very well. And it also has sliders, as you can see in the screen, so you can up your threshold if you really cannot afford an incident of that nature. This may take a bit of tuning to see, for sensitive type businesses, is it actually blocking legitimate answers? This is all sort of experimental, and we'd be happy to work with you on specifics there. Additional inputs or security for inputs such as the prompt injection attacks, even indirect prompt injection. This is a technique by where when you use the RAG, retrieval augmented generation technique on a model, so you're grounding it on your company's data, or even customers' data, what if that data has a prompt injection attack where it says, ignore all the previous instructions and do what I tell you to do from here? We have protections for that as well. Just all things to be mindful of, right? We try and abstract as much of this away as possible for the benefit of all of us. But just, it's good to know, good to keep in mind. And if you go through content safety, you will be covered for these types of things. When it comes to quality, groundedness, protected text, images, code, sort of those copyright features, we also have blocks on there, which is why we offer the copyright commitment, because we're confident that if you go through our safety systems, you won't end up in a predicament where you end up in a lawsuit or anything of that nature. I want to deep dive on a couple of these. So groundedness detection. This is where, I'm not sure if this is an industry standard term yet, but what we call ungrounding, where, it may not be sort of life or death in this scenario, but you can imagine in other scenarios it might be, or money might be on the line, where the source says Mike bought an apple. When you prompt it, it gives the wrong answer. And there you have a detection of ungroundedness, and the content safety filter would catch this. For prompt shields, again, direct prompt injection is where the user, the one who's chatting with the model, is asking it to ignore previous instructions or to do something it's not supposed to do. Indirect, that sort of prompting would be in the data itself. As part of the safety evaluations tooling, we offer a way to generate adversarial data. You may have heard of generative adversarial networks, or GANs, where two models are sort of competing against each other. One's trying to outsmart the other. And by that process, the model that you end up deploying becomes a lot savvier to these techniques. This is a similar mindset where you can generate data that you, maybe in your specific industry, in your context, might be used to get unwanted information out of the model, get it to behave or perform in a way that it's not supposed to. We have mechanisms to test all that for you. Jailbreak attacks, again, another dashboard to show the robustness against these types of attacks. You can compare multiple models, one with protection, one without, see if it's needed for your use case. Just for a bit of peace of mind, just know that before we release any of our first-party models, be it Phi or OpenAI, we do red teaming, or even for third-party models, before we put it onto our curated section of our catalog, we do internal red teaming to sort of go through various attack metrics with and without content safety to see if it passes our bar. And this is why we try to have a fast follow, we call it, with OpenAI, to where whenever they release a model, we release it at the same time or shortly after. Anytime there's a delay in that process, just know it's likely because of this. We really don't want to release something that could tarnish our reputation or end up causing customers harm in any way. So delays usually mean that we're evaluating the model, we're doing further testing, we're collaborating with OpenAI, providing feedback on how we can make this better. And just to sum it up, again, all this is built into Azure AI Studio. So a lot of it is abstracted away. Just make sure you have content safety enabled. And actually, if you want to disable it, you'll have to submit a form as to why. We take it that seriously. We don't allow it to just anyone, and we want to make sure that you're protected. I'll wrap it up here with our infrastructure. This is probably a different audience than what end users of LLMs are looking for, but this is really what powers the whole thing, right? This is the AI infrastructure that powers the creation of the next generation of OpenAI models or of Phi models, or even just the hosting of such models. So just to give some sense of credibility, Microsoft runs on Azure. Every 365 app or Bing or Edge or Copilots, all these end products that you use are running on the same services that we offer to you, be it Azure Machine Learning or OpenAI Studio, etc. I was in a call with our engineering teams not too long ago where we were coming into some issues with our service, and I had really dug on this point. I'm like, what are you guys using behind the scenes to power this? And they're like, Azure ML. And I was like, really? Are you serious? They're like, yes. So we use our own tools. That's how we can confidently give them to you, as well as we have some third parties that can vouch for us. So NVIDIA, OpenAI, Inflection, all of these groundbreaking companies use Azure to meet their scale demands. When it comes to performance, there's a benchmark out there called the ML Perf benchmark. We had submitted an entry late last year and ended up being the number 3 supercomputer in the country, passed only by I believe it was a couple of the national laboratories that have access to stuff that the general public does not yet. So we were a top cloud provider for performance and scale up. And in addition to that, just for the local audience, this global impact is being locally powered. So you may have seen these headlines in the past couple of weeks about Microsoft acquiring land or building data centers and offices. We are really, really big on this idea of having these benefits not be just to us, but be to all the regions in that we serve. So
one question there.
Yeah.
So the land in NC, right? Like Virginia, is it like more of data center?
It's the latest one is not, the use has not been publicly disclosed. I presume it'll be data center. Perhaps if there's tech talent in the area, it might be a mix of offices and data centers. But regardless, the data centers will create jobs in their own right. So this is probably the slide that the technical folks will care more about. These are sort of the highest end GPU SKUs in the AI stack. So all the way up from the H100 and soon to be announced the H200 you may have heard, and the GB200, roadmaps on those products to be announced soon. But really, if you want to be fine-tuning large models or hosting or even going into foundational LLM training, which is a whole task in itself, we have the SKUs available for you. Some of these higher end ones may be gate kept by the Microsoft account teams. So definitely, if you have a need for these, get in touch with your rep. Feel free to mention GBB. That's my team. We have to give an okay and approval to release these SKUs to customers. But just to know, for a variety of use cases, we have you covered on the bare metal GPU stack. A relatively new offering on those GPUs is Azure Confidential Computing. This was co-developed with NVIDIA to ensure that whether the data, during the training process and during the inference process, while it's at rest, while it's in transit, it's confidential the entire time. Never once is it exposed in a way that could compromise security. So all that being said, the AI stack is just one portion of the overall stack that we offer. So if you had come to us for OpenAI, open to having a conversation about how it connects well with all the other pieces of our stack. But anyway, I've talked long enough. I'll open it to questions.